Okay, so writing Verilog code in a way that everybody starts designing their own code for whatever the specification they have. Let's say if you want to write a code for a flip flop or a logical gate or any combination circuit or a sequence circuit, so you have to uh, draw what you on a paper, rough paper. In out, it's a combination of the port is uh, acts as both input and output. Okay, so and name of its connections. Okay, all of that we need to declare. So it's a simple module definition, as you can see, with the 3 input ABC and Y output. So it starts with module, whatever the example that we have taken. Okay, that module name. Okay, if it is an AND gate, if it is an AND gate. If it is a NAND gate, it's an AND. Okay, and in the brackets of A, B, C, and Y are the total ports. These are called the ports. So when you start writing a module, you should assume that the module is like a block. A block is having 3 ports of input and 1 output port. So this is a port at block level. At the boundary of the block, these are called ports. Okay, input port A, input port B, input port C, output port Y. Okay, after this declaration, you will start writing the behavior of this module. What is the functional behavior of this module? If it is an AND gate, so you will write Y is equal to A, B, C. Okay, if it is a OR gate, you will write A plus B plus C in system understandable language of OR gate. Okay, so after writing the description, the circuit behavior, you will write end module. You want to close the module with the end module. So within module to end module, your entire module definition will be there. So this is called in generic, the language they use in semiconductor. It's a module definition. Okay, so um, this module is an example. So example module definition is like this, written in this form. Okay, if it is an AND gate module definition will be written as per the behavior of AND gate. How many input AND gate? It's a 2 input AND gate or a 3 input AND gate, depending on that. Okay. Next. So while defining the input and output ports, if let's say my input port or output port is a bus, that means it's a 64-bit bus or 32-bit bus, 16-bit bus. Okay, that you need to define. You can define the range start to the end. Okay, so in an order when you represent, it will be in the end colon start. So 31 colon 0. So while writing the code, you will write the end range with the colon start range. Okay, so you need to define it while declaration itself. You cannot just change it on the later stage. You have to declare it in the beginning itself. Let's see an example with circuit. Okay, and here we are going to learn what is instantiation. Okay, here you are seeing this is your module, top module. Within top module, you have 2 submodules, I first, I2. Okay, these are 2 modules within the top module. Okay, now how do you write the code? Module top, A select C are the inputs, Y is the output. A select C, Y. Inputs A select C, output Y. Okay, and you have wire connection from internal submodules in between two submodules. Okay, so that N1 you are going to mention it as a wire. Next, how do you instantiate? Okay, so small is a module definition name. Okay, so this is module name is a small. This one is also small. Okay, this is a type of module. Okay, so let's say if it is an AND gate, it will be an AND. Okay, that means you have two AND gates, or if this is AND gate and this is OR gate, an AND gate connected to OR gate. Okay, back to back. Now, when you want to declare or instantiate a module within another top module, okay, you have to define it like this. You have to tell the name of the module like this. Okay, this small, whatever you're seeing small, is a separate module, right? Like this, you want to represent here in a top module. So you need to mention the module name, original module name, and your desired instantiated name. Okay, so this is your instantiation with your desired name. You can give any name. This is your original module, and this is your uh, representation model. Okay, so you're calling the original module and naming it as your desired name. Okay, and the port and all will be as per your usage. So A select N1. Okay, A select Y is N1. Okay, this is one way of writing instantiation, but most probably you have to write a proper order of, like if you have uh, B is a port name of this small module. Okay, and C is a connectivity coming to the B, then dot B brackets, within bracket you have C. For Y it is a Y, A it is N1. So this is a proper definition. So what you are seeing is a two different ways of representation. Okay, so this is the best way, and in real time this is how you define. Okay, so you can define, you can have as many AND gates and OR gates in your design, right? So your original module name should be the same, followed by, if you have 1,000 gates, 1,000 AND gates used in your top module, then starting with 0, okay, to 999, okay, you will name it as a and underscore 0 and underscore 1 and underscore 2 within your design. Okay, so it will be your customized name, the user defined name. See, this is a simple representation of a top module. Within this you have two submodules connected. Okay, and here also you can write properly A dot A brackets A dot B select bracket C bracket select. Okay, and Y you can write just Y, you don't need to write anything, or you can write Y bracket N1, because N1 is a wire connecting from Y to A, so you can still have N1 here. Okay, next is bitwise operators. So bitwise operators are something that you want to represent logical gates. It is more convenient. Okay, and for and you use ampersand symbol. Okay, for or you use this symbol. For XOR you use this symbol. Okay, for NAND again it is a not symbol to represent not gate. This is a symbol. not of A and B, not of A or B. Okay, so this is a representation of logical gates. Okay, these are all two input logical gates. So this is bitwise operation where you can represent like this in this fashion. Next, conditional assignment. Okay, when you have question mark, okay, and colon, you can use them for conditional assignments. So question mark and colon is also called as ternary operators because it operates on three inputs. Okay, S, D1 and D0, D0, that is here the word example that we are taking. Okay, so inputs D0, D1 and S, output Y. So Y is equal to S based on the S connectivity, S selection. Your D1 or D0 will be selected because this is a mux. Okay, it's a two input 2 by 1 mux. Okay, so for a 2 by 1 mux, the select line is very important. So how do you represent a mux behavior using this bitwise operators is using conditional assignment of question mark and colon. Okay, so the meaning of this statement is if S based on select line of which one you want to choose, then Y is equal to D1, else Y is equal to D0. Okay, how do you express numbers? So if you want to express numbers in a Verilog code, how do you represent? Okay, N single approaches and D and followed by the code, the number. So N represents the number of bits. That means the bit length of your number. If it is a 4-bit, 8-bit, 16-bit, 32-bit, 64-bit. So you have to uh, tell the bit size. Okay, the number of bits. Next, B is generally is a base. It can be binary. If you it's a binary code, hexadecimal it will be H. If it decimal it will be D. If it is an octal it will be O. Okay, and the number here is a numbers representation in terms of 0 and 1s. So the value expressed in whatever the base. If it's binary, binary representation, hexadecimal representation. Okay, and it can have X and G also. So X is a don't and G is a high impedance. So X value representation is in neither 0 nor 1. G is a high impedance. Okay, and you can have underscore for a better readability, but tool it is for user understanding. Tool for tool it is not a problem. Okay, you differentiate the 4-bit. Okay, if you have 16-bit, you can differentiate every 4 bits. It's up to how you want to differentiate. You can use an underscore. It's a privilege, but not needed. So it is a here you can see multiple representations. Okay, these are two columns. Okay, Verilog stored number, Verilog and stored number. So here you can see it's a 4-bit binary code, and the stored number here is 1001. And here it is a decimal 4-bit decimal 5. The representation of 5 in machine understandable language, it will be stored as 0101. Okay, 8 8 this is the 8-bit binary 1001. So when you say 8, it will fill up the 000. Okay, total 8. Okay, 12-bit 12-bit hexadecimal FA3, it will be converted into a proper binary code of 1111 1001 0011. So tools, systems, a machine understandable language is always binary 0 1. Okay, so it will always convert it to whatever in form you give, it will automatically convert. So 8-bit B binary, this is a 8-bit, you can see the same, you can follow the same code here. 8-bit octal representation, this is the representation of octal 12. Same here, the first 4 bits you can see double x 0x, it's the same. Okay, and you have double z, it will be the same. So whatever you have x and z representation in the binary representation, it will have the same. Okay, hexadecimal 7 is represented like this. 4-bit, as it is a 4-bit, it is represented like this. Okay, and if you do not represent anything and you reverse the symbol and you represent like this, then tool will consider it in this form 000 dot dot 0001, because tool, it did not give any the bit length. Okay, next 12-bit hexadecimal 0, you will have 12 zeros. Okay, and the precedence of operations in Verilog, when you write Verilog code, so not is the highest precedence, not followed by star slash percentage. Okay, star is for multiplication, slash is for division. Okay, so percentage is a module, and plus addition, minus subtraction, left shift, right shift, arithmetic shift of left and right. Okay, less than or equal to, greater than is equal to for comparison. Equal is always in Verilog, you have to mention 2 times. Equal symbol you have to mention 2 times. Not equal is the not symbol with equal, 1 equal. Okay, and is ampersand, and is a, you have a not gate in front of and. XOR is this symbol. Okay, and not XNOR is a, you have one inverter followed by XOR. Same here, and this is your lowest. Ternary operator is the lowest, but still how it is up to how you want to use it.